Hi, today we are looking at learning target 8E, which is on direct variation. Okay, so first of all, direct variation is a linear function whose y-intercept is 0. So remember that when we say linear function, that means when you graph it, it's going to be a straight line. And if the y-intercept is 0, that means that the line is going to be going through the origin. Okay, so that's what we would be looking for visually on a graph if that graph happens to represent direct variation. Sometimes you'll also hear this called proportional relationships, and so those are kind of interchangeable terms. So if they say, does this equation represent a proportional relationship, or does it represent direct variation, it's really asking the same question. Now, if you have an equation that is modeling direct variation, there's something that's called a constant of variation, and essentially that's going to be the slope in the equation. So for example, if I gave you the equation y equals 4x, we know from our last learning target that slope-intercept form looks like y equals mx plus b. Now in this equation, 4 happens to be what's in front of x, right? So that's m, that's our slope. Notice how there's nothing added or subtracted over here for b, the y-intercept, which is why, again, we say the y-intercept must be 0. Okay, so yes, this is direct variation. Our y-intercept is 0. This is a linear function. And so my slope in this equation is 4, and that's what we would call the constant of variation. What that tells us is that the y value is always 4 times whatever the x value is. So y is varying directly with x. It's always 4 times the amount. Okay, so we're going to take a look at what happens with the graphs of direct variation, the equations, and then the tables, because we want to be able to tell if something is modeling direct variation no matter what type of information we're given. So if we're given a graph, if we're given the table or the equation, we want to know. Okay, so if we're looking at graphs, remember we said that it's got to be a straight line and it's got to go through the origin. So both of these pictures are showing direct variation. They're both straight lines. Now this one has a positive slope, and so you can see that when we look at the generic equation y equals a times x, right, which is kind of the same as y equals m times x, a, that's your constant of variation or your slope. Okay, when a is greater than 0, therefore a positive number, we get a line that's increasing from left to right, still going through the origin. If you have a constant of variation or a slope that's less than 0, so it's negative, that's when we get a decreasing line, but again, it still has to go through the origin. So a straight line through the origin, that's what makes it direct variation. Okay, so here are 7 different graphs. I want you to take a minute and think about which of these graphs show direct variation. There could be more than one answer, so look at all of them closely, okay, and select which ones you think show direct variation. Okay, so let's see how you did here. As I look at each of these graphs, I see A as being a straight line going through the origin, so I'm going to circle this one as being yes, I think that is direct variation. Now line B, it looks like a straight line and it hits the origin, but then we kind of have this V shape here, right? So it's almost like it's 2 separate lines that meet at the origin. So this is not a single straight line, so this is not going to be direct variation. All right, looking at graph C, this is a curved line. It's kind of like a U shape. Yes, it hits the origin, but it is not a straight line, so not direct variation. All right, line D, this one starts at the origin, but again we have sort of a curve here, and so I got to cross it out, not direct variation. E, that's a straight line, but not going through the origin, so it can't be direct variation. Line F, straight line through the origin, I'm going to circle that one. And line G, it's straight, but not through the origin, so I'm going to cross it out. So in the end, we had 2 of the 7 graphs that were showing direct variation. Okay. So let's take a look then at equations of direct variation. When you have the equation, we say it's generally of the form y equals ax, where a just can't be 0, and we say that y is varying directly with x. Okay, so again, connect this back to y equals mx plus b. Y equals mx is the same as y equals ax. We're just using a in this case to represent the constant of variation, but it's the same as m, or the slope of the line. And again, we're not adding or subtracting anything on the end because our y-intercept has to be 0. So we want to be able to look at an equation and tell whether or not it represents direct variation. If it does, we want to be able to identify the constant of variation. So if I have y equals 3x, I would say this looks like a linear function, y equals ax. There's no adding or subtracting here, so there's no intercept other than 0. So I would say, yes, this is direct variation, and my slope of this line is 3, so that is the constant of variation. Okay, and then looking at this one, y equals 2x minus 6. So I have the y equals ax part, right? My slope of this line is 2. But I have this minus 6 here, so that means my y-intercept is down at -6. So this line will not go through the origin, therefore we would say this is not direct variation. If it's not direct variation, then we can't have a constant of variation. It still has a slope, but it's not a constant of variation, so we don't have to identify one. Okay, another way you can be looking to tell whether an equation is modeling direct variation is you can make the graph of the line. Okay, and so we could make an input-output table where I can plug in different values of x. So for example, when x is -2, 5 times -2 is -10, minus 1 more is -11. When x is -1, 5 times -1 is -5, minus 1 more is -6, and so on. When I plot those points, notice it's a straight line. It comes real close to the origin, but it doesn't actually go through there. So this one is not direct variation. Now again, if you could have looked at this and seen our y-intercept was -1, and said, okay, that's not going to go through the origin, it's not direct variation, that's great. But this is a good strategy to use, like say on an MCA test, if you forget exactly how to tell, make the graph and see, does it go through the origin? That's sort of the key point we want you guys to take away from this. All right, let's try this next one here. Y equals -3x. So again, if you aren't sure whether or not this equation is going to be direct variation, make an input-output table. So -3 times -2 is 6. -3 times -1 is 3. -3 times 0 is 0, and so on. And so when we make the graph of those points and draw the line, we can see a straight line through the origin. So yes, this is direct variation. And again, we can tell here that the intercept is going to be 0 because there's nothing being added or subtracted away. Okay, and so last part of this one, what was the constant of variation? We go back to our slope right here, so our constant of variation would be -3. Okay, so take a minute here, take a look at these two equations. Which one do you think represents direct variation? Okay, so the last thing we want to look at is properties of tables. So let's say that you were given an input-output table and you were asked, is this direct variation? What we're looking for is that the ratio between y and x should always be the same. So one should be a constant multiple of the other, okay? And so what I'm going to do is I'm going to look at, for each ordered pair, what is it when I do y over x? So 7 over 1, that's just equal to 7. When I do the next point, 14 over 2, that's also equal to 7. When I do 21 divided by 3, that equals 7. 28 divided by 4 is equal to 7, and 35 divided by 5 is equal to 7. Notice how two ratios that are equal to one another, we call that a proportion. So this is a proportional relationship, which I mentioned earlier in the video. That's another word for direct variation. So the ratio is always the same. As long as the ratio is always the same between y and x, that means it's going to be direct variation. Okay, last table. So same type of thing, right? I've got my input-output values. When I start to look at those ratios, for the first one, y over x, 3 over 1, that equals 3. But when I look at my next point, 5 divided by 2, that's only 2.5. That does not equal 3. So those are not the same ratio. When I look at 7 divided by 3, that's like 2 1/3. So that's still not the same as either of the other ones. 9 over 4, that's going to be 2 1/4. So still not the same. And then 11 over 5 is 2 1/5. So none of these fractions are the same as one another. It's not proportional. It's not that one variable is a direct multiple of the other, and therefore we can say this is not direct variation. Okay, so to summarize, we are looking to make sure that our equation is y equals a times x, so there's nothing being added or subtracted for the y-intercept. When we look at a graph, it's got to be a straight line through the origin, and when we look at a table, the ratios have to be the same for each pair of x and y values. All right, so to wrap up here, please record one thing that you learned or were reminded of and any questions that you have. So again, try to make sure that you put one thing for each prompt, and we'll follow up with all of this tomorrow in class. Thanks, guys.